Hello and welcome. In this video we will discuss the Coulomb's law of electrostatic force between 2-point charges. Suppose we have 2-point charges Q1 and Q2 separated by a distance r. Then the Coulomb's law states that the force between these 2-point charges is proportional to the product of the charges, and it is also inversely proportional to the square of the distance between them. So combining these two, we get F equals to K Q1 Q2 divided by R square newtons. Force is measured in newtons. In this equality, K is called the Coulomb's constant, and K has a value equals to 8.9875 times 10 to the power 9. The units are Newton meter squared per coulombs squared, or we can use 8.99 10 to the power 9 Newton meters squared per coulomb squared for convenience. Now, after experiments, K is found to be equal to 1 divided by 4 pi epsilon 0, where epsilon 0 has a value 8.8542 times 10 to the minus 12 coulomb squared per Newton meter squared, where epsilon 0 is called the permittivity of free space. Permittivity of free space. Now, the force between these point charges is repulsive if the charges are of the same nature, same sign. For instance, Q1 and Q2 if both these charges are positive, these are separated by distance r, the force acting on these particles is repulsive. Now, the force on Q1 due to Q2 is F12, because force is a vector, and force acting on Q2 due to Q1 is F21, and according to Newton's third law, the forces are equal and opposite. So F12 is equal to minus or negative F21. In this case, the force is acting in this direction, force acting on charge Q1 due to charge 2, and the force acting on Q2 due to Q1 is F21. Now if the charges are of opposite sign, Q1 and Q2, and these be 2-point charges separated by a distance r, let this be a positive charge and let this be a negative charge. In this case, the force is attractive. If so the charges are of opposite sign, which is one of the charges is positive, the other charge is negative, then the force is attractive. And if the charges are of the same sign, which is either both of them are positive or negative, the force is repulsive. Now as we can see, the force on Q1 due to Q2 is F1, excuse me, F12 in this direction, and the force acting on Q2 is F21 due to Q1 is pointing in this direction. And the force F12 is equal and opposite to the force acting on Q2 due to Q1. Now let us see a simple example to find the force between 2-point charges, each 1 Coulomb, separated by a distance of 1 meter. Q1 is equal to Q2 is equal to 1 Coulomb, 100 coulombs, and the distance r is 1 meter. Now from the formula, F equals to 1 divided by 4 pi epsilon 0 Q1 Q2 divided by r squared. We can substitute the values of Q1 and Q2, and 1 by 4 pi epsilon 0 can be conveniently written as 8.99 10 to the power 9, and the two charges are 1 times 1 divided by 1 squared. That gives you 8.99 10 to the power 9 newtons as the force between these 2-point charges. Since the charges are of same sign, the force is repulsive. Thanks for watching this video.